Hi guys, welcome back to my channel. I hope you guys are having a wonderful day. Okay, so before getting into the question, I would request you all to please subscribe to my channel for more videos. If you go back to my previous videos, you will see that I have uploaded sums on LPP using graphical method, mainly on maximization function. So this is the first sum which I am going to show you on minimization problem. If you are aware of LPP, you should know this by now, that LPP graphical method can be done using two way. One is maximization and one is minimization. So you need to know both the methods because you never know in which method you get the question, isn't it? And to be very honest, this kind of questions you will get it of around like 5 marks, so it's really scoring. All right, let's get into the sum. Okay, as you can see here, it's minimization. So mean z equal to 200 plus x plus 500y. ST stands for subject to, and this is the objective function. X plus 2y is greater than equal to 10. 3x plus 4y is less than equal to 24. I have to solve this using minimization. Now know one thing, excuse me, whenever you're saying this, that one is greater than equal to, one is less than equal to, see the question. Your question is in minimization. By now you should know this, that whenever it is minimization, means your entire equation should be greater than equal to. Okay, you need to bring the form in this way. If it is maximization, it should be less than equal to. It's minimization, so greater than equal to. So this sum is okay. For in case of this one, it's less than equal to. So what I'm going to do, simply I'm going to change the sign. How to change the sign? You just need to just put just change the sign simply. Just this will be this is positive, so this will be minus 3x. Since this is plus, this will be the opposite, so this will be minus 4y, and this will be greater than equal to minus 24. Okay, if the question would have been something like minus 3x plus 4y, then to change the sign, this would have been plus. So plus 3x minus 4y greater than equal to minus 24. Okay, so let's do that. Alright, so the first thing which we need to do, that is the first step, is convert the inequalities into equality. Alright, so for the first one, this is okay because minimization and it's greater than equal to, so I don't need to change anything. So let's just write it. First write minimization, mean z is equal to 200x plus 500y. This one will be as it is. X plus 2y will be simply equal to 10. I'm going to change this because it's in less than equal to. I have to make it greater than equal to. Simply change the sign, that is minus 3x. This will be minus 4y. This will be greater than equal to minus 24, and this is done. Now I'm going to change this inequality into equality. How should I do it? Minus 3x minus 4y equal to minus 24. So my equations or the constraints, so the constraints are this one, and the second one is this one. Okay, now the next step is I'm going to find the value of x and y individually for each constraint. So let me make two rectangular boxes then. This is for the first one, this one is for the second constraint. Okay, x, y, x and y. Right, let's see the first one. When x is equal to 0, when x is 0, 2y equal to 10, y will be 5. So when y is equal to 0, x will be 10. Okay, for this one, when x is equal to 0, y will be 6, and when y is equal to 0, x will be 8. Okay, now the next step is I'm going to plot the graph. Okay guys, as you can see, I have plotted the graph. Now let's see the first coordinate, that is when x is 0, y will be 5 means this point, and when y is 0, x will be 10 means this point. So let me just join the 2 points. As you can see, I have joined the 2 points. Now let's see for the second constraint. When x is 0, y is 6 means this point. When y is 0, x is 8 means this point. So I'm going to join the 2 points once again. Okay, as you can see, I have joined the second point as well. Now I need to find the initial basic feasible solution. See the question. Okay, as you can see here, the first constraint is greater than equal to. And which one is the line for the first constraint? This one. This one. 1 1, and this is for the second constraint, right? So the first constraint says that it is greater than, means it has to be somewhere above, right, upward side, and the second constraint is lesser than. So this is the second constraint, it has to be lesser than. So my initial basic feasible solution is this portion. Let me just mark it. Let this be point A, this will be point B, and this will be point C. Guys, mind it, you cannot make this portion as initial basic feasible solution. Why? Because my first constraint says that it is greater than, isn't it? So first constraint greater than means upward. If this would have been, like, if you choose this one, just check this, then therefore this is the first constraint line, greater than means upward, and the second constraint is lesser than means inward. So can you find any initial basic feasible solution over here? No, you cannot find it. That's the main reason this portion is the my initial basic feasible solution, that is known as IBFS. Okay, now I know the coordinate on this one. What is this? That is 0 comma 5. I know this 0 comma 6, but I don't know the coordinates of point A. So I'm going to find out how. Simply I'm going to equate the two constraints. Alright, as you can see, I have written the two constraints. This is constraint 1 and constraint 2. I'm going to find the value of x and y from the two constraints. How? So let me just do it. Alright, so this will be minus 3x minus 6y equal to minus 30. What I'm doing, simply I'm multiplying minus 3 with constraint 1. Okay, right, and this one will remain as it is because the coefficient of x is 1. So this will be minus 3x minus 4y minus 24. It is same. Now if you need to cut it, how it will be eliminated? This will be minus 3x minus plus 3x will be eliminated. This will be minus 6y plus 4y will be minus 2, and this will be 6 minus 6 because minus 30 plus 24 is minus 6. So my y will be, the negative signs will be eliminated, y will be 3, and if you put the value of y in any one of the two equations, you will get x as 4. Therefore the point A, I am getting the coordinates, that is 4 comma 3. Now my next point is I'm going to find the optimized value with how many points? With 3 points, A, B and C. Okay, as you can see, I have written here A, B and C. These are all the x's, these are all the y's. What I'm going to do, I'm going to put the value of x and y in my objective function. Okay, this is my objective function, 200x plus 500y. Okay, so if I put 200 into 4 plus 500 into y, I will get the value as 2600. Similar manner for the second one, if I put 200 into 0 plus 600 in 6 into 500, I will get the value as 3000. And for the last one, similar manner, I will get it as 2500. Now, this question is minimization. I need to find the optimized value. Till now, what I have done, maximization, I have done maximization, and in case of maximization, I used to compare and find the maximum value out of 3. But since this question is in minimization, so you need to compare and find the minimum value out of the 3. So the minimum value out of the 3 is this one. Okay, that is 2500. So I can write it this way, that my optimized value is optimized value is 2500, where x is 0 and y is 5. Okay, so this is my ultimate answer. Thank you so much guys for watching. Stay tuned for more videos on minimization. Since this is the first one, I will come up with more sums on minimization, and so that you will not have any problem in understanding this topic. Thank you so much for watching. Don't forget to subscribe to my channel. I will be posting videos every weekend. Since this is like, I have recently started my channel, that's the main reason I'm posting it like number of times, but after a few days I will start posting it just on Saturdays and Sundays. Okay, thank you so much. Don't forget to like and subscribe. I will see you in the next video with minimization problem. Thank you. Bye bye. Have a nice day.